students. Today we are going to discuss about trigonometrical identities. Okay, but before we are going to start this particular topic, let me give you a brief formulas on which you have to apply these while you are solving identities. These are the trigonometrical ratios. Okay, so first ratio we have sine of theta. This is equals to the ratio of perpendicular by hypotenuse. Okay, perpendicular, hypotenuse, base. How to recognize? Suppose this is the acute angle theta, whose trigonometrical ratios you are going to express over here. The side opposite to theta is the perpendicular. Okay, the side opposite to 90 degrees is the hypotenuse, and the remaining side will be the base. Now don't expect that this is always going to be the base. Okay, I repeat once again, the side opposite to angle theta is the perpendicular, the side opposite to 90 degree, the longest side of a right angle triangle, is the hypotenuse, and the remaining side is the base. So we have the Pythagorean theorem, the square of hypotenuse equal to sum of squares of remaining two sides. Now continuing this, we have the second ratio, cos of theta base by hypotenuse. Okay, then we have tan theta, which is equal to p by b. Okay, then we have the cot theta, which is equal to b by p. Okay, then we have the sec theta, which is equal to h by b. Okay, then cosec theta, which is equal to h by p. If you observe these six ratios, the first is the reciprocal of the sixth, second is the reciprocal of the fifth, and third is the reciprocal of the fourth. Okay, that is, if you sum up the reciprocal relations, okay, then we have sin theta into cosec theta 1. This means sin theta equal to 1 by cosec theta, and cosec theta equal to 1 by sin theta. Okay, so these are the outcomes of the same reciprocal relation, that is sin theta into cosec theta equals to 1. Next, this is one pair. Okay, second reciprocal pair is, we have cos theta into sec theta. This is 1. Look at this, cos is b by h, sec is h by p. So both are reciprocal of each other. So we can write this as cos theta equals to 1 by sec theta, and sec theta equals to 1 by cos theta. Okay, so this is another pair, reciprocal relation. The third pair is, we can write tan theta into cot theta equals to 1. This implies that tan theta equals to 1 by cot theta, and cot theta equals 1 by tan theta. Okay, so this is the third relation, reciprocal relation. Okay, this is the outcome if you write in sequence, sin, cos, tan, cot, sec, cosec. Okay, then we have two additional formulas which are very useful when you are doing identities. Okay, these additional formulas are tan theta equals to sin theta by cos theta. Okay, and cot theta, which is the reciprocal of tan theta, okay, is opposite, that is cos theta by sin theta. Okay, now let's move on to the main topic. That means we are going to prove the identities, sums based on identities. But before that, we must have the three basic identities to know. Okay, the three basic identities which are going to be applied while solving the trigonometrical identities are, namely, first, for any value of theta, okay, we have sin square theta plus cos square theta equals to 1, okay. This means we can also understand that sin square theta equals 1 minus cos square theta and cos square theta equals 1 minus sin square theta. So these are the outcome of this relation, right? The second relation is for any value of theta, sec square theta minus tan square theta is 1, okay. This means for sec square theta we can write 1 plus tan square theta, okay, and for tan square theta we can understand sec square theta minus 1, okay. The third and the last identity is cosec square theta minus cot square theta is 1, which means for cosec square theta we can write 1 plus cot square theta, and for cot square theta we can understand cosec square theta minus 1. So these are the three basic identities and the formulas discussed over here, which are going to be applied when you are going to solve the trigonometrical identities, okay. Now what are the rules? First of all, try to understand the basic rules. Rules for solving identities. First and foremost thing is that pick up the longest expression, okay. There are two sides, left hand side, right hand side. So the longest expression has to be picked up, okay. Second is that try to focus on the basic identities, okay. Basic identities means these are the expressions what you need to search and focus in the question, okay. Third is that if this is not clear, then change to sin cos, change to sin theta or cos theta, okay. That means in the given expression, okay, if there is tan theta, you can write sin theta by cos theta. If it is cot theta, you can write cos theta by sin theta. If it is sec, you can write 1 by cos, and if it is cosec, you can write 1 by sin. Let me tell you why I told you to express in sin cos. Remember when you were told in algebra, okay, when you began the equations, let the number be. You used to be given that it is x. Why did you think about rest of the 25 alphabets? Because we have been focused as x something unknown number. Now from then onwards we began using x frequently, okay. Whether it is a simple equation, simultaneous equation, quadratic equation, it is a spontaneous feeling that we get, let the number be x. Similarly in trigonometry, sin and cos are the most common trigonometrical terms, ratios. So it is better if you convert it to sin cos, then we focus in this first expression, okay. So once you express in sin and cos, okay, you think about this, this and this relation. And please, last but not the least, the fourth rule, pay attention on other side, because that is only the result, okay. So suppose you began with left hand side, keep watching the right hand side, what expression you want to get, that is the result. So let us now apply this, okay. Now children, let us take one question applying these four rules. First, okay, prove that sec A plus tan A into 1 minus sin A equals cos A, okay. Now as per the rules discussed over here, we are supposed to take the longest expression, so let this be the longest expression. That means begin with LHS, left hand side. So this is sec A plus tan A into 1 minus sin A, right? Now sec can be converted into 1 by cos A plus this is sin A by cos A into 1 minus sin A, okay? LCM comes to cos A, this is 1 plus sin A, okay, into 1 minus sin A. Now what do you get? A plus b into a minus b, a square minus b square. So it is 1 minus sin square a by cos A. Okay. Now keep paying attention on the right hand side. You want cos A. Now you know 1 minus sin square a. Now this is the benefit, you know, why I wanted to convert to sin cos. So we got this expression. We can now replace 1 minus sin square a as cos square a. So in the numerator we have cos square a divided by cos a. Since you want cos a, so one cos a terms get cancelled. So we are left with cos a. So once you get cos a, you write this is equal to RHS. Okay. So I think applying sin cos, it becomes easy for you to solve the questions. And in boards, 90% questions are based on sin and cos. Now you have to focus the method on which I have taught you just now. Let's take one more example. Now let us take one question. This is question number 2. 1 plus tan square a into 1 minus sin a into 1 plus sin a equals to 1. Obviously the longest expression is left hand side, okay? So we are placing left hand side, that is 1 plus tan square a into 1 minus sin a into 1 plus sin a, right? Now as I told you, after selecting the longest expression, focus on the basic identity. That means there is one plus tan square a, there is one square term, and you have seen that 1 plus tan square theta is sec square theta, okay? So can we replace this as sec square theta, okay? And this is 1 minus sin a into 1 plus sin is 1 minus sin square a, okay? Now 1 minus sin square a is, that is cos square a. So can we replace sec square theta into cos square theta? And while discussing the reciprocal relations, we have seen that cos into sec equal to 1. So sec square theta into cosec square theta is 1. Okay, this is equal to RHS. Suppose you have got this expression 1 plus tan square equal to sec square. Now think about a student who didn't catch this expression. He remembers the method. Why not convert it to sin and cos? Look at the third step. Change to sin or cos. So let's now focus this expression by changing to sin and cos. Okay. So let us start from here. Okay. This is the expression on the left hand side. Now see, I am converting this by sin cos method. 1 plus tan means sin by cos. So can I write tan square a as sin square a by cos square a? This is 1 minus sin square a. Okay. On taking LCM, we have cos square a plus sin square a by cos square a. Okay. This is the simplified expression for the bracket. And 1 minus sin square a, you know it is cos square a. Okay. So these two get cancelled. What is left? Sin square a plus cos square a. What is that? 1. So this is equals to 1, equal to RHS. Okay. So I think you won't find any problem while solving these expressions based on sin cos. Okay. At least in your textbook you might come across those questions. Okay. Maybe few 1 or 2 questions which are not based on this method, changing to sin and cos. But trust me, at least 90% questions are based on this. Okay. So I think now you can solve these questions. So these are all based on class 10 concepts. Okay. So thanks for watching.